Aha. This one is pretty tricky if you first look at it. I mean, do you let u be, I don't know, 1 plus e to the x? You let it be the square root of x plus e to the x? I mean, what do you do? Well, remember your two general tips. The first one is that you want the derivative of whatever you pick to also be inside. And typically it's the inside part of the function. There's a part of this, even though it looks incredibly confusing, there's one that satisfies both. The inside part of the square root, x plus e to the x, its derivative is 1 plus e to the x, which is right there, right? So, and it's the inside part of the square root. So both. Wow, that sounds like magic. So the derivative is 1 plus e to the x dx. And that is right there. That's du right there. And then we've got, that's u. And so this is equal to the integral of 1 over the square root of u du. Oh my goodness, my colors. Okay. All right. So then to find this one, you have square root on the bottom. It's better to bring it up as u to the negative 1/2 so that we can use the backwards power rule. So this would be u to the positive 1/2 and then divided by 1/2, which is the same as multiplying by 2 plus c. And so then this is just equal to 2x plus e to the x to the 1/2 plus c, or you can also write it as 2 square root of x plus e to the x, and then all plus c. Mustard. Okay. Then how about the integral? Now we're going to start getting crazy. Cosine of x squared over the square root of sine of x squared. Oh my goodness gracious, great balls of fire. Fire! What do we do? What do we do? That's crazy. We're dividing, we're multiplying, my goodness. Well, relax. If you take a deep breath, you might go, hey, look, even though this doesn't make any sense, right from the get-go, we do have sine of x squared, which is an inside, so we should try that. And if you do try that, that's why I said that, even if you're not sure, you just try something. Because sometimes you'll just stumble upon the right answer. With practice, you get better. Okay, so then if you get the derivative of sine of x squared, well, that's cosine of x squared. And then by the chain rule, remember, this is cosine of x squared times 2x. Ooh, whoops. I forgot my dx here. Sorry. You should always have the dx. If I don't write it, that means I made a mistake. If I don't write it, that means I made a mistake. So, okay, cosine of x squared, 2x dx. And notice that because of the chain rule, it added another x in here, which is this x that we have right here that we thought was extra. So here, cosine of x squared times x almost is exactly the same here. The only difference is that you need a 2 here. So, well, that's easy. Put a 2, 1/2 on the outside, and bada bing, bada boom. Bada bing, bada boom. du. We did it. du, u, done. 1/2 the integral of 1 over the square root of u du. Wow, that was awesome. Awesome. Okay, so this is equal to 1/2 the integral of u to the negative 1/2 du. So this is 1/2 times u to the positive 1/2 times 2. Plus c is almost exactly like the one we just did. And so, the last part anyways, get rid of those 2's, and that would give us a sine of x squared all to the 1/2 and then plus c. That's it. Okay, now this one might seem, easy compared to the ones we just did, but it's the first one we've done on the handout that has limits of integration. So, that changes things a little bit. Remember, you have two options, and I'll show you both, but the beginning starts off the same. So you pick your u, which is going to be just x plus pi, and so then du is going to equal to simply the number 1 dx, because pi is a constant, so the derivative of that is 0. And so this is a really simple substitution. This is going to be du, and this is going to be u. Okay, now, as far as the limits of integration go, you have two options. Remember, one is you leave the limits alone, but you have to make sure that you go back to the original variable. Now, this might not seem like a big deal because we've been going back to the original variable on every single problem, and it's not a big deal. The big problem is when you don't do it and you plug them in. So even though it seems simple, mistakes happen all the time. So what this basically means is that you will get rid of the limits of integration. So you just treat it as cosine of u du. You find the antiderivative, which is sine of u, no plus c here because it's a definite integral, but you do not plug in 0 and pi. You go back to the original value for u, which was x plus pi, and then you can plug in 0 and pi. Okay, now it doesn't seem like a big deal, but it is. Trust me. It's very easily forgotten. So then this is going to be sine of, if I plug in pi, I'm going to get 2 pi minus sine of, if I plug in 0, I get 0. So this is just equal to 0. Okay, now the second option, and sometimes a little better, is that you the second option is that you switch the limits of integration from from original, I'll just say original because typically it's x, but it could be t or z or whatever, from original to u. Okay, so what that basically means is that you take your limits of integration, your original ones, 0 and pi, and what you do is you swap those for u values. So you go, okay, well, I know that u is equal to x plus pi, so then when x is equal to 0, u is going to equal to 0 plus pi, or simply pi. When x is equal to pi, u is equal to pi plus pi, or 2 pi. So then what happens is your original problem goes from being from 0 to pi of cosine of x plus pi dx. That was our original problem. You turn it into going from the new limits of integration, which are from pi to 2 pi of cosine of u du. Now, then you find the antiderivative, which is just sine of u. And in this case, now that you've swapped these values from x's to u's, now you can just simply plug in pi and 2 pi. Now, notice this seems like more work in the beginning, but typically this part right here, the switching of the limits of integration, you can typically do it in your head because it's usually a small values. They're small values. And so doing this is usually pretty easy. And let's do an example. The next one we'll do it, and we'll do it in our head. So to kind of show you guys, and then you guys can pick whichever one you like. Guys or gals, you can pick. If you want to leave them alone, as long as you do it correctly, I don't mind either way. Okay. All right, so this again is not too challenging compared to the ones we've been exposed to. We would let u be between sine and cosine. The obvious choice in this case is going to be cosine, and together with the negative, because that's the inside part of the function. So we're going to make that equal to u, and so then du is equal to the derivative of this, which is just sine of theta d theta. So we have du here, and then we have u up here. And so then we're going to do what I said we were going to do. So here we're going to have e to the u du, but then we're just going to switch these from 0 to pi over 2. I'm going to turn them into u values, and we're going to do this in our head. So what we're going to do is we're going to go, okay, so negative cosine of 0, well, cosine of 0 is 1, so this is going to be negative 1. And then pi over 2, if you plug pi over 2 into here, you get negative cosine of pi over 2, which is 0. And that's it. So you just swap the limits of integration. And the great thing about this is now you have just e to the u. You're going from negative 1 to 0, and you don't have to go back to the original theta or anything like that. You know, you're done with that. So here now all you have to do is e to the 0 minus e to the negative 1. So this is 1 minus 1 over e. And that's it. So I prefer swapping the limits of integration. I think it's much simpler and less confusing once you get the hang of it, because you don't have to go back and forth and trying to figure out what they are. But it's your choice.